Hello, I'm Chuck Bardron with the University of Georgia Center for Invasive Species and Ecosystem Health. I am the Associate Director for Invasive Species and Information Technology, and today we're going to talk about some tools to assist in the early detection and rapid response process for invasive species. The University of Georgia Center logo is these four arrows. To find out more about the center, you can Google Bugwood or go to bugwood.org. But basically, the four arrows represent the different areas in which the center works: forestry, agriculture, invasive species, and then using information technologies to improve these areas. So let's talk about early detection of invasive species. Early detection of invasive species usually starts when somebody, in this case a hiker, is hiking on Kennesaw Mountain and comes across a plant, garlic mustard in this case, that he recognizes and is not aware of existing previously in Georgia. So he is involved in his local exotic pest plant council or invasive plant council. And so he has contacts. Those contacts get together. They have a volunteer pool day. They go in, they pull a bunch of the garlic mustard, really do a good job of before and after of what the garlic mustard looks like. And at the end of the day, have a huge success by bagging up a lot of garlic mustard. So great example of early detection and rapid response. But actually, even though work has continued, we later found out that Scott Ranger had taken a sample from Kennesaw Mountain, and it was in a newspaper, the dated, May 10th, 1989. And a graduate student at the University of Georgia actually did his master's work on this population. But because there was no database out there of invasive plant occurrences, then that historical knowledge left as personnel changed at Kennesaw Mountain, and as these the folks who had worked in the population and documented the population moved on or weren't involved in groups like the Georgia Exotic Pest Plant Council. Sacred ibis is another example I'm going to bring up and I'm going to come back to later as a success story. But sacred ibis is a bird native to Africa. They think it was released from the Miami Metro Zoo during Hurricane Andrew. There's been money and a lot of effort going in to eradicate these, to keep them from breeding and disrupting the native ibis populations. So remember the sacred ibis, and we'll come back to it in just a little while. But when you start talking about databases and networks and information on invasive species, there's a lot of different programs out there. And all these programs store their data in slightly different formats, or they're very specialized to a region or to a taxa. Or in some cases, like the plants database, they're trying to record all the plants in the U.S. or North America, not just the invasive ones. And when you have a lot of different databases, you end up with a lot of different maps, and each one of those maps can show slightly different distribution of the species. As you can see, here's different maps showing Japanese honeysuckle. And if we blow up the Japanese honeysuckle distribution in Georgia, we can see there's a lot of counties in Georgia that don't have Japanese honeysuckle, or at least according to this map, that don't have Japanese honeysuckle. But in the case of Japanese honeysuckle, it's so widespread that unless somebody made the effort to document it in each one of the counties and send a herbarium specimen in, then there may not be that documentation. And anytime you start talking about databases and GIS and doing mapping, then usually ArcGIS comes into the equation. But myself, who's a computer scientist first and a invasive species biologist way down second, when I open up ArcGIS and I don't use it but a couple of times a year, I'm kind of lost. I'm figuring out what layers are and everything else when it comes up. So, if you don't have that experience, then it's something that is not easy and not intuitive for you to use. So what do we need? We need a common operating platform for invasive species data. And we need a way for easy electronic reporting of species. So when something like garlic mustard's found in a new location, it can be recorded and there can hopefully be a response to it. So in 2005, we started development of a program we call EDMAPS, and EDMAPS stands for Early Detection and Distribution Mapping System. And now our goal is for this to be the national platform for invasive species, all taxa of both plants and animals, early detection and distribution mapping. We started in 2005. Our motto is really invasive species mapping made easy. Until recently, this is what the homepage for EDMAPS looked like. But we now have been working on a new design, a more responsive design because of the massive use now of smartphones and tablets, as well as screens everywhere from 10-inch laptop screens to 27-inch high-resolution monitors. You want something that adapts for whatever platform you are on. And so we've completely rebuilt the EDMAPS website to be more responsive to different resolutions and to different size screens. And the unique thing about EDMAPS is the reason it has been successful over the last almost 10 years now is because we've had a lot of different partners and a lot of different buy-in from different groups. The Forest Service, Forest Health Protection, has definitely been the largest supporter of EDMAPS, but the National Park Service, U.S. Fish and Wildlife Service, the U.S. Army Corps of Engineers, USDA NEFA, APHIS PPQ, as well as nonprofits such as the Nature Conservancy, companies such as Invasive Plant Control, as well as individual states, as well as Canadian provinces, have all contributed to making EDMAPS what it is today. And I saw this picture come in with a EDMAPS report, and it's a cane toad that got stuck in a fence. And I said, really, when you start looking at all these different systems, this is really what happens. You may have a national park on one side of the fence and a national forest on the other side of the fence, but those two agencies can't easily share data between themselves. So by uploading that data for the forest and for the national park into EDMAPS, then they can look at it and see what is both on their property and on the adjacent property with a different landowner. EDMAPS has been adapted by most states throughout the country in some form or fashion. The different colors here kind of represent the different regional projects. Orange up in the New England area is the original IPANE or invasive plant atlas of New England states. And IPANE, which was one of the projects that EDMAPS actually modeled itself after, is now actually hosted and maintained through the EDMAPS system, and IPANE is the New England portal to EDMAPS. The yellow states represent what we call the Mid-Atlantic Early Detection Network, or MAIDEN. The red states are the Southeast Early Detection Network, or SEDEN. The green states are the Great Lakes Early Detection Network, or GLENDON. All the states in blue are part of a project that we call EDMAPS West. Florida down there, because of the unique species, both of plants and animals, their project is kind of off by itself because of just the climate there. They have a lot of different species, and their smartphone app's called I've Got One. Texas, Alaska, and really California as well, all have their own state-level programs that share data back with the EDMAPS system. And there's been some activities in the other states, but not as widespread as the ones that are in color. So zooming out on the EDMAPS homepage, you can see that we've got some educational resources. We've got the primary supporters, recent reports. We have a random report image here. We have statistics, the smartphone apps list, as well as the different projects. When you go to the website and you click on distribution maps, you're able to view distribution maps both by taxa, plants, insects, plant pathogens, or wildlife, or by state or county. And if we go to one of the specific projects, in this case, the Mid-Atlantic Early Detection Network, then we're going to kind of show you how the projects work. And in this presentation, we're going to use MAIDEN, or the Mid-Atlantic Early Detection Network, as the example. But all these concepts, all of these, even the apps I'm going to show you, are very similar when you go to one of the other regional projects. So when you're on the MAIDEN website and you want to report something through the web, you choose your state, you choose what you want to report. So we're reporting a plant. You can start typing the plant into the this drop-down menu. It gives you a list of options. So if you type in ligustrum, it gives you a list of the ligustrums. You choose one. You can scroll down on the page, choose your point for where you saw the ligustrum, and then you can also now, as well as put a point, you can draw a polygon in this area to designate the distribution of the species. The rest of the reporting form is fairly simple. You can add images as well as additional comments. When that report is submitted, you're given a thank you, as assigned an ID, and then you can go into the My EdMap section and view those reports and edit those reports as well. As soon as that record was entered, though, in this case in Maryland, it was sent to the state verifiers in Maryland. The state verifiers here are Curry Codd with the Maryland Department of Natural Resources, as well as Jill Swearingen and Mark Fry of the National Park Service. And they're able to go in, view the outstanding records, click on the record, see a picture, and determine whether or not, based on different criteria, that record should be released into the EdMap system or not. And sometimes they, can put, hey, it's incorrect, delete it. With this, if they don't, I didn't include a picture, so, how can they really know that it is Chinese privet without going out there? So they may end up contacting me to get more information about the record. So one example where this actually worked really well is, this is Judd Patterson with the National Park Service. He went in and saw one of those sacred ibis that we mentioned earlier. He came in, reported it through the website. He saw it at lunch. It went onto the website. Tony Pernas with the National Park Service got the email alert, got on the phone, and within an hour of the report of the sacred ibis, the sacred ibis in question was removed. So a real example of how early detection rapid response can work once you have the infrastructure and the mechanism for reporting in place. And going back to that Japanese honeysuckle picture we saw earlier in the plants database, now in EdMaps, Japanese honeysuckle has been documented in every county in the state of Georgia. The next part of EdMaps after the reporting part is obviously the distribution mapping part. So you can go in very similar to the reporting. You choose, you want to view a map of a plant. You choose what plant, and you're given a county map showing what counties that plant has been found in. In this example, we're looking at Tree of Heaven. We also have options where you can download that the data that's behind this in an Excel format, a KML format, a Garmin GPX format, or as a shapefile. We also have now incorporated sharing tools where you can embed this map onto your own web page, a couple of different ways, and also have a link. You also can share this on Facebook, Twitter, Google+, Pinterest, Blogger, or by email. One thing that was always a requested feature was being able to easily download a JPEG of a map, so you could easily put it into PowerPoint. And so that feature is now there with the download link shown here. You're given a map. It shows when the last observation, which for this case was on June 7th, and when the map was generated on June 11th. So you're given very quickly the information that you would need so you can incorporate into a PowerPoint presentation. We also map the points when we have an individual point, when the record goes beyond a county, onto a Google map. And here's an example of some of the clustered points that you can see. You can click on one of those points and view all the information about that individual record. Recently, we've also added a GIS feature to this, which is actually using the ArcGIS server. So even though ArcGIS server, from my standpoint, it's pretty difficult to use, there are cases where users need that power and need that flexibility. And so now that is one of the tabs and one of the ways you can map reports. We're looking at some other features, some new mapping system ways of displaying data. This would be clustered by state, clustered by county, kind of showing the distribution, with different counties shaded differently. A grid-based clustering is something else we've looked at. We'll probably end up doing some kind of quad-based mapping to show, where things are, when you can get to a finer scale, basically, than a county level scale. And here's just showing a couple of different backgrounds to go along with that. The Esri, Mapbox, OpenStreetMap, OpenMap Server, just some different layers that you can use to go along with that as background data. And here's just a few more maps. Here's what's called a heat map that works well for some species, kind of showing where the hot spots of an infestation is. And then just another way of looking at the point maps and seeing where distribution of a species is, as well as at the national level. This is an interesting map because this shows everything in EdMaps clustered by state, so it gives you an idea of what states there's less data from as opposed to what the states there's more data for. And then this is a very similar map, but showing it at the county level for all the data for all species that are in EdMaps, and then again showing clustering at a couple of different levels. So since we started EdMaps, we now have over 2.6 million records in EdMaps, and about all but 1 million of those have actual lat long to go along with it. The others are more county summary records. We also have 4,500, that's covering 4,500 different species. We've had over 6,700 different users. Those are actually different sources of data, individuals or organizations who have submitted data anywhere from, an organization that may have submitted 100,000 records that was everything that's ever been found in their state, down to the user who has made 1 or 2 reports. We received 12 million hits last year from about 750,000 visitors, and we're getting multiple submissions from each of the different projects every day. One of the big things we were looking at is you've got to have some kind of background to go along with a system like EdMaps. You've got to have that verification. You've got to have that identification tool. So here's an example where somebody sent in pictures of a species that they saw. They didn't know what it was. Probably the best possible example of how a system like this is useful, because the user knew, hey, this is something I don't know what it is. Let me report it. Well, it turns out in this case, and if we were sitting in a room with an audience, I'd ask you what its species was, and usually nobody knows what it is. But it's actually just an albino raccoon, which is rare, but not a new invasive species that is found. As we've aggregated and pulled in all of this different data, we're able to do different kind of maps. Looking at a program like Spotted Wing Drosophila, you can do kind of county level maps over time. Kudzu bug, which is a new pest in the southeast, you can see how it spread from, the kind of Atlanta, Athens area out to cover multiple states across the country now. Another example of just showing maps over time. When you have the data, when you have that fine of data, you can go in and show the impact of a species throughout a year and how it spreads over a year. This is the map that I always call the, where you don't want to travel in Florida map. These are the large constrictor sites, snake sightings and removals in Florida, most of which are Burmese pythons, but you can also see the other examples of mostly pet releases of other species. And the python's a good example. The snake in the grass. It's a major problem, become a major problem in Everglades National Park. Major impact on the native mammal population. And so when, the iPhone came out in 2007, then the way it was released was, your life in your pocket, the ultimate digital device. And when Steve Jobs did the keynote, when he released it, he said, the iPhone is three things. It's a phone, it's a music player, and it's an internet communicator. Well, I argue that more importantly, for reporting and helping to manage natural resources, it's also a GPS, a camera, a field notebook, as well as a field guide, all in your pocket, which pretty much makes it the ultimate, and I'm referring to all smartphones now, the ultimate always with you pest and invasive species reporting tool. So when it came to the pythons in Florida, the question came up is, hey, can we build an app for that? And so we did. We worked with a lot of partners with the Park Service, as well as the Florida Fish and Wildlife Conservation Commission, the Nature Conservancy, and the University of Florida Center for Aquatic and Invasive Plants. And we created an app for reporting not only pythons, but all invasive species in Florida. And what happened was that app became very popular. We got a lot of good press on the app, and it led to folks contacting us and saying, hey, can you create an app for this? Can you create an app for, my part of the country? Can you create a field guide for this? And so now, I joked this was the iPhone 5 screen. We now filled up more than will fit on the iPhone 5. The iPhone 6 is coming out later this week with a bigger screen, so I guess we'll have more space to fill up with new apps. But we've now created apps from everything from regionally focused field guides and reporting apps to doing even some decision support tools for stink bugs in cotton, as well as some invasive management apps and apps that just kind of give you alternatives to invasive plants. And so now I'm going to go through what one of the reporting apps looked like. Now, this is the Mid-Atlantic Early Detection Network app. You can go in. I'm kind of showing the top and the bottom here, but it's a dashboard format where you can view species by category, all species you put on your list, the state list option, negative survey option. You have your upload queue, your login, and more options. So if you just kind of go through, you click on categories, you're given the different categories, you're given a list of species, you can search those species, you can sort by scientific or by common name. You also can go in and select certain species that you want to be part of your species that show up on your species list. And here's just an example of the reporting form. You have what species you're reporting. You can take a picture or pick one from a library. You have your latitude and longitude, your time spent collecting it, what the area of the infestation looks like, what the density looks like, as well as some notes to go along with that. And what we've added is now with this button here, the original use of this button was so you could move your location. So if for some reason, the GPS was not showing you exactly where you were, if you couldn't get to exactly where the population was, you were able to pick up the point and move it somewhere else. Well, we said, what if you also could draw in a polygon? So now we have the ability to draw a polygon either by dropping points and it filling in the area from there, or by just sketching the polygon on the map. And then that saves it back into the report and you're reporting a polygon instead of just a point. We're still working on the state list for some of the apps. It's been implemented for the EdMaps West app and will be coming to all the apps, where if a state has a specific list, then that list will be available. Negative survey is also something that's very good. Anytime you have a citizen scientist or even a professional project, you never know if people aren't reporting things because they aren't going out and looking, or because they're just not reporting anything. So now we added the ability to do negative survey, where you can go in, choose an area that you're looking for the species in, choose what species you're looking for, draw a polygon, and document how much time you spent looking for the species. And then both of those go into the queue for uploading. And so everything is saved on your phone, and then you hit this upload button to upload it. And you can wait until you are on a Wi-Fi connection to do the upload. You can basically do all of this on the phone without a live data connection when you're out in the field, if you're somewhere that you don't have a good data connection. And with the apps, you can go through all this without creating an account. But creating an account is a very important part of the process, because you cannot actually submit the apps unless you are logged into the app and have an account. And so what we've done now is we've integrated the registration form into the app. You don't have to go to a web page and sign up. You can do it directly into the app. And if you're part of the Sentinel Plant Network, then you want to put SPN as part of the registration form as your organization, and then that way that can be tracked as we go through and collect the information. But you also have a choice to put what state you're in, and then you can create your username and password here as well. The rest of the app is just kind of general information about EdMaps, about the partners, and then links to the other apps as well. And there's a feedback button. This is very important. If you run into a problem with the app, then if you fill out this feedback link, it sends us an email. We know what kind of device you're using, what version of iOS you're using, and what version of the app you're using. And that really helps us to track down any problems you may have with the app. Moving over to the Android format, I'm just going to quickly go through this. Very similar interface to the iPhone, slight different tweaks because of differences in the interface, but overall the gist is the same. You can still draw polygons 2 different ways. You can sketch, or you can drop points. There's also a field guide part of these apps, as I did not show in the iPhone, but where you can look at pictures, you can view write-ups about the species, and you can actually view the distribution of the species right from the app. And again, just slight differences here. You can see if you're an Android user, then this interface looks more like the Android apps you're used to, and iPhone users look more like what the iPhone information you're used to. And again, we've got the very similar registration form, where again you can put in SPN as your organization. We also have the same feedback button here, where we can know what device you're using, what Android version you're using, and what app version you're using. So if you have a problem, then we can help track down what that problem with the app is. Here's just the iPad interface. Similar format, but the split screen. It does give you a nice look at higher resolution look at the pictures. And it's a little bit easier to obviously draw some of the polygons on the iPad than it would be on an iPhone. And we found that a lot of users, when we were doing trainings, were going out in the field with their iPads, and so we decided to make sure that the app fit and worked good on an iPad as well as it works on a phone. For whatever reason, we're seeing a lot more use of the iOS apps. I think iOS users are just a little bit more keen to downloading and trying apps out. We probably are getting close now where we're getting about the same number of reports from the Android apps as from the iPhone apps. And I think that this year in most projects, we're seeing over this summer, this field season, that for the first year, we're getting more reports coming from the smartphones than from the web interface. And it honestly makes sense because it's a lot easier to report from a phone than it is to report going back to the website and report things. One thing we've started adding to the system as part of these smartphone apps is insects as well. Emerald ash borer, Asian longhorn beetle is good examples, but we're working with the regulatory people in each state and nationally to make sure that when those reports go in, they're sent to the State Department of Ag and the state health director with USDA APHIS. So those records, those species can be followed up on and can go to the proper databases. And we have an alert system that kind of shows how this process works. When something's considered actionable, when something's a regulatory species, then an email is sent to the regulatory officials and it's not shown on the map, and no alerts go out until it's been completely verified. In other cases, it just goes to a state verifier. Sometimes, depending on where you are in the country, it automatically shows up on the state, and then alerts are sent out. And so one question I always get is, well, who cares? And so I started thinking about that. And, maybe with the pythons, we can show a cartoon of, pythons wiping out glades, mammals, and, obviously the people sitting there, why should they care? But I did a presentation in Indiana a few years ago, and I really looked at, okay, well, Indiana is 23 million square acres. 15 million of that is farmlands, of which 5 million of that is soybeans. And so that's a $4.2 billion a year soybean industry in Indiana. Well, kudzu bug is a pest of soybeans that they've seen, 10 to 30% impact to soybeans in Georgia when not managed properly. Well, that equates to real dollars if the kudzu bug is viable in Indiana, because you start talking about a 10% decline, and you're talking about $427 million in 1 year. And with 30%, you're talking about $1.28 billion. So this is why early detection and rapid response for these pests is very important, because it may not be the big python that is scary. It may be the little kudzu bug that is really what's scary. So to wrap up, when you're talking about EdMaps, all of these, everything I've shown you today is available now. We've tried to make it as fast and as easy to use as possible. We're aggregating data from other systems. We're not trying to replace some of the other projects that are out there that work well and have their own need. But there's also, it's nice to be able to go to one place and see everything at a national level. Our primary focus right now is looking toward complete county level distribution of invasive plants. And then just having this tool to do the early detection and rapid response through smartphone apps, data entry tools, email alerts, and then this network of expert verifiers. EdMaps is a tool that can be used to enhance existing programs. It's up, it's working now. Regulatory pests, we're now taking some of that data, but it was not meant to be, in competition or replace programs like NAPAS and IFAS that are the regulatory systems. And one thing we've learned, and as you're using these systems and implementing tools like this, is that the public needs something that's as easy as possible. And so, in Florida, the I've Got One name came because they have a telephone number for reporting pythons. This I've Got One, this 188 I've Got One. And so, we took that, and that's the phone number. The web address that takes you to the EdMaps Florida website is I'veGotOne.org, and we named the app I've Got One. And so there's one consistent message, one easy way to make sure that you know where to go to report things. And I think what's really important, and my oldest son, when he was 4 years old, our future generation of naturalists, our future generation of ag specialists, of foresters, of farmers, they grew up using some of this new technology. And, my youngest son using an iPad, I think he was 3 years old at the time, you know, they're going to be so used to this technology that we've got the opportunity here to really take advantage and use their expertise to move invasive species reporting forward. So, as you watch this presentation, things to think about is how can you integrate this into your program? What would help? We're talking about adding in the better maps that we showed, but also news alerts. So when MRS is found in a new state or a new county, then your phone, your app would send you an alert letting you know about that. What features are needed? What features need to be added? We're always looking for suggestions of how we can improve things. And then how can this tool be used for professionals and for citizen scientists? And that's what we're seeing. You get both the citizen scientist that is really concerned and really interested in the project and in invasive species, and it's a way that they can easily help. But we also have seen a lot of use by professionals, that they're using as part of their day-to-day activities. And then I think long-term, this is going to be good base data that can be used for modeling and for climate change research. And who knows, with Google Glasses and the Apple Watch and all the new technologies that are on the horizon, where we're going to be in another 5 or 10 years. So that's all the information I have. Thank you for bearing with me and watching the presentation today. My email address is cbargero@uga.edu, and then the EdMaps URL as well as the apps.bugwood.org. So please email me if you have any questions, and thank you very much for listening today.